So we have a few techniques that we use for factoring. Sometimes they say factoring is more of an art than a science. One technique is what we call the greatest common factor. Now that's what we did on the last problem. If you remember, we had 60x squared minus 40x. So what we did was we said, well, what do they have in common? Or in other words, what could they both be divided by? What's the largest expression? Well, 20 goes into 60 and 20 goes into 40. So we factored out a 20, and then they both had an x, at least one x, so we factored out an x. Then you're thinking about, well, what's 60x squared divided by 20x? See, this is the greatest common factor right there. Sometimes we call it the GCF. Minus, and then think about 40x being divided by 20x. Now, you don't have to write it that. You can. I see students do that sometimes. They like to. But then you're simplifying this. That's just going to be 3x, and then minus, and then you're going to simplify that, which is just going to be 2. And if you remember, that was our answer in the last problem. Okay? So greatest common factor, or GCF, it's the largest expression that divides, I guess, no, I hate to say divides, goes into, I'll put goes into each term. Okay, so that might be kind of unclear. Okay, but I'll give you another example. That'll help. All right, so it says factoring the greatest common factor. So I'm looking at 6x cubed y cubed, 45x squared y squared, 21xy. I take it one piece at a time. First, I look at the coefficients, 6, 45, and 21. So you could write those, 6, 45, and 21. What's the biggest number that goes into each one? Now, one way to do it is start with the smallest one, 6. Does 6 go into 45? No. Okay, so that's not going to work. Then think about, well, what is 6 made up of? 2 and 3, right? 2 times 3 is 6. Well, does 3 go into 45? Yes. Does 3 go into 21? Yes. Okay, so 3 is the greatest number that's going to go into those coefficients. So my GCF is going to have a 3 in it. Now the next part might be easier to look at. You've got x cubed, x squared, x. What's the most that they all have? Just an x, right? They don't all have x squared, they don't all have x cubed, but they all have at least one factor of x. Okay, and then you do the same thing for y. I got a y cubed, a y squared, and a y, so they all have at least one y. Okay, that then is the GCF. 3xy will go into each of those terms. Now, I don't usually write out the division part. I just think about, okay, here is the first term. If I divided that by 3, that would leave me a 2. And if I took an x out, I'd have an x squared. If I took a y out, I'd have a y squared. Plus, and then I go to the next term. Well, if I divide by 3, that gives me 15. If I took an x out, I'd have an x left. If I took a y out, I'd have a y left. Plus, and then I look at this one. Well, if I divide by 3, that would give me a 7. The x already came out and the y already came out. So I don't have any left. This is factored. It's in terms of multiplication. I have a greatest common factor, 3xy, times this polynomial in here. Now the great thing, one of the great things about factoring is, well, we use it for lots of things, but you can always check it by distributing. So if I multiply that in, do I get 6x cubed y cubed, right? Think about the multiplying. And then if I take 3xy times 15xy, I'd get 45x squared y squared. And then if I took 3xy times 7, I'd have 7xy. And sure enough, if I erase all this, that's what we had at the beginning. Oops. That's what we had at the beginning. Okay? Hey, wait a minute. How come I don't have a 21? Because I didn't go 3 times 7. All right. Well, now that looks like a mess, but it was supposed to be a 21. Oops. It was a 21 XY. You're all wondering why I had that 7 there. Okay, so you can always check your factoring by multiplying. And the first step to factoring, you always want to check and see if there's a GCF first.